In the last lesson we had, and one lesson before that, we were changing fractions into decimals, and they all terminated, meaning ultimately they came up with a remainder of 0. Not all decimals do that. So we want to take a look at some fractions that do not have terminating decimal form. These will have something called repeating decimals. So let's take a look at two examples. Suppose somebody says to change 5/6 into decimal form. So we know that we're going to take 6 and divide it into 5. We're going to add a decimal point and at least 1 0. I happen to know this is not going to terminate, and I'll add as many zeros as I need until I observe a pattern. All right, 6 does not go into 5, but it goes into 50. It's going to go 8 times. 8 times 6 is 48. I subtract for 2, and it hasn't terminated, so I add a 0. 6 goes into 20, well, it's going to go 3 times. 3 times 6 is 18, and subtract for 2. It hasn't terminated, so add a 0. 6 goes into 20 3 times. 3 times 6 is 18. Subtract for 2. Hopefully you're beginning to see the pattern, and if I added zeros infinitely, I would begin to just get more and more 3s. This can be written as 0.83 with a bar over it, and the bar indicates repeating. Once you see the repeating pattern, you put a bar over it. You notice the bar does not extend over the 8, just over the 3. Let's look at one more. Let's look at 4/11ths. And then we'll do some real exercises. Except I went too far with that. All right. Let's change 4/11ths into decimal form. We're going to divide the 11 into 4.0. We'll see how many zeros we need to add before we recognize the pattern or it terminates. 4 does not go into 4, but it goes into 40. It's going to go 3 times. 3 times 11 is 33. Subtract for 7. Didn't terminate, so I'll add a 0 and bring it down. 11 goes into 70. Well, it's going to go 6 times. 6 times 11 is 66. Subtract. I get a 4. Didn't terminate, so I add a 0, bring it down. 11 goes in there 3 times. 3 times 11 is 33. Subtract for 7. Add another 0. It goes in there 6 times for 66, and hopefully you're beginning to see a pattern. The pattern on 4/11ths is 0.36, but the entire 36 repeats. So some numbers have 5 digits that repeat in a pattern. So it just depends. When it is a repeating decimal, sometimes you will be asked to write it with this bar. More often than that, you're going to be asked to divide it and round to a particular place value, which is what you're going to do in your exercises. Now, if you had been working with this, it is 0.363636 ... which is a way to indicate continuation. And somebody said to round to the nearest 10th. You would round to this 3. The 6 would tell you to round up, and it would be 0.4. But if someone told you to round to the nearest 100th, that's this 6. The 3 would say don't round up, and it would be 0.36. If someone said round to the nearest thousandth, the 3 is in the thousandths place, the 6 would tell you to round up, and it would be 0.364. So depending on what place value you're told to round, you get a completely different answer. Sometimes you write repeating decimals like this. There are times when you might want to write out the pattern and put ... to indicate it continuing. Most frequently you're told to round to a place value. So let's see what your problems ask you to do. Each one of these, I believe, is going to have 3 parts. It asks us to round to the nearest tenth, the nearest hundredth, and the nearest thousandth. So the first thing we need to do is establish what the quotient is. So I'll start out with 15 into 1.0. Well, 15 goes into, it doesn't even go in there. So I'm going to have to put a 0 and add another 0. 15 into 100. Well, I think it's going to go 6 times. I might need to do my multiplication over here, but I'm going to shortcut that step. 6 times 15 is 90. And I subtract, and it hasn't terminated, so I add a 0 and I bring it down. 15 goes into 100. I'm sorry. 15 goes into 100 another 6 times. And 6 times 15 is 90. I subtract for 10, and I add another 0. I can do this as long as I want. It's going to be 6 again. So I can tell that this decimal, if I were asked to write it out with repeating notation, it would be 0.06 with the bar over it. If I were asked to write it out with the dot notation, it would be 6, 6, 6, 6, ... It goes on forever. But I'm asked to round it. So, rounding to the nearest tenth. Well, I have 0.0666 and so on. Here's the 10th place. The 6 tells me to round it up, and this will be 0.1. That's the nearest tenths. Let me pause for just one moment. All right, but if you were asked to round this to the nearest hundredth, and I'll write it down again. And remember, you could write down as many 6s as you need. This 6 is in the hundredths place. So I look one place behind it. It says to round up. So this would be 0.07. And that is this fraction rounded to the nearest hundredth. And then finally, if it said thousandths, 0.0666, and of course I can write as many as I want. This is the thousandths place. This 6 tells me to round up, so it is 0.067, and there it is, rounded to the nearest thousandth. So they appear to be very different numbers, and they are, depending on where you're asked to round. All right, let's look at another one. All right, I have 2/3. I'm going to write it to the nearest tenth, hundredth, and thousandth. All right, I'm going to divide 3 into 2.0. We'll see how far I need to go before I see my repeating pattern. 3 doesn't go into 2, but it goes into 26 times. That gives me 18. Subtract, add a 0. 3 goes into 26 times. 6 times 3 is 18. Subtract, add a 0. 6 times, and it's very clear what this repeating pattern is. I could call it 0.6 with a bar over it, or I could call it 0.66 ... that just shows that that 6 goes on forever. So, but I'm asked to round it to the nearest 10th, 100th, whoops, and 1000th. All right, 0.666 ... This is the tenths. This says to round up. This will be 0.7. Same number, 0.666 ... This is the hundredths. Round up, 0.67 in the hundredths place. And finally, 0.66666. I could write as many as I want. The thousandths place is right here. This says to round up, 0.667 is rounded to the nearest thousandths. You have to have your number written out at least one place further than where you're going to round to. All right, let's look at, now this 4/7. If I can divide this until I see a repeating pattern, but it's going to be a pretty long division. All right, 4/7, 7 into 4.0. 7 goes into 4. It doesn't go into 4. It goes into 40 5 times. That's 35. Subtract for 5, add a 0, bring it down. It goes into 50 7 times. 7 times 7 is 49. Subtract for 1, add a 0, and bring it down. You can see I am not seeing a repeating pattern yet. It goes in there 1 time. 1 times 7 is 7. Subtract for 3, add a 0. 7 goes into 30. It's going to be 4. 4 times 7 is 28. Get a 2. You can see I am not repeating yet. 4 goes into 20 2 times. That's 14. Get a 6. Bring down 0. It goes in there 8 times. That's 56. I get a 4. I add another 0. Now finally I got my 40 again. It's going to go in there 5 times. And the minute I got that, and I'm sorry it's probably almost invisible at the bottom, I can see that it's about to repeat again. All right. Literally what 4/7 is 0.571428, and that 6 digits is what repeats. It will be 571428, 571428, 5, and so on. So all of the sevenths, 1/7, 2/7, 3/7, they all have not exactly this pattern by any means, but it is a 6-digit repeating pattern. So let's take a look at that to the nearest 10th, 100th, and 1000th. All right, 0.571428 ... All right, tenths. There's the tenths. That says round up. So to the nearest tenths is 0.6. Write it down again. 0.571428 ... to the nearest hundredths. This 1 says just stop it. So it is 0.57. We did not round up there. Nearest thousands, 0.571428, and it goes on. The 1 is in the thousandths place. The 4 behind it says just stop. So this is 0.571. Rounding it to different places. Okay, I think we have one more we can look at. 5/12. 5/12, 12 into 5.0. It's going to go in there 4 times. 4 times 12 is 48. Subtract, add a 0. It's only going to go, it's not going to go twice, just one time. 1 times 12 is 12. Subtract for 88, and then bring down a 0 to make 80. It's going to go in there 6 times. 6 times 12 is 72. I got another 8, which means it's another 6 for 72. And I'm beginning to see a repeating pattern. So this is 0.416666, and it is the 6 that is repeating. So tenths, hundredth, thousandth. All right, 0.4166, and I can write as much or as little of it as I need. I have to go out one place past the tenths. That says drop it off, 0.4. 0.41666 out to the nearest hundredth. This 6 says round up, so this will be 0.42. Then finally, 0.416666 to the nearest thousandth. This 6 says round up, and this will be 0.417. So on each one of these, divide till you see the repeating pattern, and you can write out as many digits as you need. To round to the tenths, you have to go out to hundredths. To round to the hundredth, you have to go out to thousandths. To round to the thousandths, you have to go out to 10 thousandths. Okay, give that a try.